So, I still have a stale view count number. I gotta let that come up a little bit. All right. So, at the end of last stream. All right. So, at the end of last stream, I demonstrated the bug. The bug is that we're crashing in here. This status is not correct. And I know from when I investigated this previously that the sequence of events that's happening is it's starting this chunk and then finishing it twice. And so the second finish, the status has been changed by the first finish and the second status there. However, I did not see any signs that it started it twice, so I don't know how it can finish it twice. If it would make sense if it would like started it twice, nested inside itself in some way, and then the finishes would happen. Like I could imagine a scenario. I don't have a scenario for how. I don't have a scenario for how this bug is occurring, so we're going to have to just try to figure out where everything is happening and coming from. So the way I was debugging this before was just trying to view the sequence of abandons and finishes and creates and try to see what was going on, and that was how I got the data that it was finishing the same one twice, but wasn't ever starting it twice. So I think we'll start with a different attack, which is we'll set the mesh workers to 1 so that there's no thread fighting between workers. There will still be the render different attack, which is wasn't ever starting it twice. So I think we'll start with a different attack. So I think we'll start with and try to see what was going on, and that was how I got the data that it was finishing the same one twice, but wasn't ever starting it twice. So I think we'll start with a different attack, which is we'll set the mesh workers to 1 so that there's no thread fighting between workers. There will still be the render thread versus the worker thread, so I would expect. All right. So at the end of last stream, I demonstrated the bug. The bug is that we're crashing in here. This status is not correct. And I know from when I investigated this previously that the sequence of events that's happening is it's starting this chunk and then finishing it twice. And so the second finish, the status has been changed by the first finish and the second status there. However, I did not see any signs. I would expect it might still happen, but it might be a threading bug. We'll have to see. So why does it go down? Like I'm tilted down and it turns sideways. Oh, because I push forward, that's why. Because if you only tilt sideways, it doesn't orbit very well. It does not seem to be happening. Suspicious. Alright, I'm going to guess it only happens if there's at least 2 threads. It might not even happen with 2, it might only be threads. Happens if there's at least two. I'm going to guess it only happens if there's at least two threads. It might not even happen with two. It might only be able to happen with a certain number. In which case, if it really is a threading bug, it's almost certainly just something not being protected by the mutex, and hopefully I can just do that and fix it really easily, but who knows. Well, I don't know. It's not happening with two now. My computer does not have that many cores. This is not going to run well, but maybe make it happen faster. Oh, max mesh workers. I can't exceed max mesh workers. All right, the other thing I had to do to make this happen was I turned off VSync. All right, the other thing I had to do to make this happen was I turned off VSync. Which means, there it happened. With VSync off, it wasn't happening, presumably because the renderer isn't submitting requests as fast. With VSync off, the renderer is submitting requests at whatever the frame rate the thing is running at. And I'm in the minimized memory mode with the short view distance here. So you can see the frame time is fairly small. There it goes. Oh. I must have been holding on a key that skipped by the assert or something. All right, the other thing I had to do to make this happen was I turned off VSync. Which means, there it happened. With VSync off, it wasn't happening, presumably because the renderer isn't submitting requests as fast. With VSync off, the renderer is submitting requests at whatever the frame rate the thing is running at. And I'm in the minimized memory mode with the short view distance here. So you can see the frame time is fairly small. With VSync off, presumably, with VSync off, it wasn't happening, presumably because the renderer isn't submitting requests as fast. With VSync off, the renderer is submitting requests at whatever the frame rate the thing is running at. And I'm in the minimized memory mode with the short view distance here. So you can see the frame time is fairly small. There it goes. Oh. I must have been holding on a key that skipped by the assert or something. I wasn't holding down space though, so I don't know why it's aborting like that. That seems different. It's aborting without bringing up a dialog box, seems like. Oh, that's the regular bug. Oh, abort. Hey, I was holding down A. Alright, so... And since the system that's going wrong is the mesh chunk processing system, the mesh chunk status system, it seems most tempting to look there, but I'm not sure that that is actually the guilty party. So, but let's just do a quick check. I think I did this before when I was testing this in the fork. So get chunk status needs to be inside. something. Okay, so it's called inside another thing, which we'll have to check. Oh, it's explicit there anyway. Get chunk status. Okay, here. This is inside manager mutex, right there. That's that one. This is inside manager mutex. Okay, and then this one is still, yeah, inside manager mutex. Okay. So that one's always inside manager mutex. Abandon mesh chunk. Inside of Alec, so we'll have to verify Alec. That's inside manager mutex. This is part of the shutdown sequence. Okay, so that's that. Finished caching. Now this is called externally, so it locks manager mutex itself. So its processing is done inside manager mutex. Get chunk status Alec. This is inside manager mutex. Yeah, it's only called inside manager mutex. And that brings us to the end of that structure. So I don't think it's that structure that's going wrong. Something else is going wrong. And triggering that. Okay, so somehow we call finished twice. Now we call finished twice if finished twice. Now, okay, so triggering that. Okay, so somehow we call finished twice. Now we call finished twice if that's handled in the renderer. The renderer is the one who calls finished right here. So the renderer goes through and pulls this queue of incoming meshes from the server, for lack of a better term. Okay, so somehow we call finished twice. Now we call finished twice if that's handled in the renderer. The renderer is the one who calls finished right here. So the renderer goes through and pulls this queue of incoming meshes from the server, for lack of a better term, and discards it right here. So what we can do is we can say yes, and the is the one if that's handled in the renderer. The renderer is the one who calls finished right here. So the renderer goes through and pulls this queue of incoming meshes from the server, for lack of a better term, and discards it right here. So what we can do is we can say yes, received chunk. I don't need the new line. I think I don't need the new line. And we'll see if we are receiving the chunk twice. So the idea is we have to move far enough to cause chunk generation to happen. That's what's triggering the bug. Okay, there we go. And right there, you can see chunk -70, receive chunk -70. So we got the same chunk twice in a row on this side. So now let's look at the thing that adds that to that queue. So now let's look at on this side. So now let's look at the thing that adds that to that queue. We just keep working backwards to see where this is coming from. Get from queue, non-blocking. So that if it's mutex false, otherwise we're in the mutex, we try to mutex, we get the item. Right, so we want to see it being put in the mutex, that's right. So we want built meshes. We want to see where we add it to built meshes. See if it's being added twice. Here's where it's added. Here's where it's Here's where it's added. All right. Okay, so there's the received info. Now let's see if we see the added info. None of these match at all. Added, received. How are we receiving all this stuff that we never added? Okay, right. So part of it is that we're adding things we don't want to include. Okay, right. So part of it is that we're adding things we don't want to include, I think. No, we're only showing the add if has triangles is false. We're only showing received if has triangles is false. So why do these not match? Oh, because this can fail. No, but that feels in the wrong direction. How do we receive something we never added? So that's what seemed to be happening. How are we receiving all those chunks? What? Those numbers just don't match. There was the same count of each one, but they were totally different numbers. Am I printing different numbers? There's 5 of those and there's 6 of those. That doesn't make much sense. Here we go. There were 4 and 4, and look, they just don't even match. Has triangles false. Okay, are we looking at the same cases? This one is has triangles false. This one was... No, wait, sorry. Has triangles false is this case. This case is has triangles true. Okay. Where was the... That's an yes. Has triangles false. Okay, so I'm printing this in the wrong case. That's why. Has triangles false. Okay. Has triangles false. Okay, so I'm printing this in the wrong case. That's why. this case that I want. Right, it's this case that I want. Okay, good. Now we should be able to see what's going on. Good. Now we. Okay, good. Now we should be able to see what's going on. Yay! Look, they match. The other thing was sending through all the physics state, and I was just checking the wrong flag. There's a stagger. Like here's a thing where it received an extra chunk. That didn't have corresponding thing, unless it's possible the output is screwed up. Output isn't buffering right. Maybe the output isn't thread safe? The SDL stuff. Alright, so it hasn't triggered though. Trying to actually get it to fail here. I don't know why it's not triggering now. Start again. This thinks there's still a thread running. This thread, I've lost the stack on it. That's annoying. It's not even inside a... It's not even in blocking. But it's in SDL. I don't know. I don't know what that was. No way to debug it. Don't tell me that adding the debug output is making this bug go away. It always happened by this point. Uh-oh, I've just lost the ability to trigger it. There it goes. Receive chunk -0.6. What if I do this? Oh, there. No, we got a different crash in SDL2. I wonder if these things are not thread safe. It would be crazy if this wasn't thread safe, but maybe there's like a config flag to throw to force it to be thread safe or something. What is the syntax for that? There it is. Oh, LCL. Yep. Non-capitalized. But it's possible that this... Oh, okay. It's not. Added, received. Okay, so... I actually did 3 times. It's pretty bad. Alright, so is it possible that multiple threads... Alright, so is it possible... It's pretty bad. Alright, so is it possible that multiple threads are trying to complete the same one? That might be the case. Maybe I didn't do something correct there. We update it to processing. There's a processing state. Yeah. Get next task. Okay, if it's already processing, we don't need to worry about it. Etc. Okay. Then we iterate over them, and we say, etc. Then we say, okay, it's ready to go. But it needs triangles, so we force it to status processing, and then we found task. Do we ever check its status? No, we don't. So if it's already processing, okay, might break the physics, but probably that was the bug. Might break the physics, but okay, might break. Okay. Might break the physics, but probably that was the bug. Let's check the physics. Physics is working. Okay, physics seems fine. Oh, but we still had the same bug. Added -1, received, added, received. So we still managed to add the same chunk twice. All right, so let's. All right, so let's. Triangles. Yes. What's the macro for this? C mesh chunk X for a world. For world X, I bet. Even though that doesn't make any sense. You don't really need X on both of them. If it doesn't happen right away, it's not going to happen. I don't know. Maybe it needs to be a specific area that I cross that triggers it every time. No, it's been different numbers, though. They're not updating, though. Nothing's actually happening. Try again. Yeah, I'm still debugging the thing I'm still debugging the thing I talked about at the end of the last stream, if you were there for that. The MCS set the next time, probably. That wouldn't be a bug. Set the next time, probably. The MCS set the next time, probably. That wouldn't be a bug. Okay. What do we see? We hit accepting on some thread. Then we hit accepting on the same thread. On a different thread, probably. And then we added and the MCS. Okay. What do we see? We hit accepting on some thread. Then we hit accepting on the same thread. On a different thread, probably. probably. And then we added on a different threads. We should print the thread IDs or something here. Okay, so it seems like it accepted it twice, even though the whole point is that, in fact, the next line here sets it. It's not chunk status processing. We set it to status processing. And this is all inside a mutex right here. Burp. It's all inside the manager mutex. So nobody else should ever be able to see it between these two states. Nobody else is supposed to be able to query this data structure while we're updating it. But clearly two people accepted it. All right, well, let's see. Do we have the thread ID somewhere? Thread ID. Yep, okay. This is not atomic. This doesn't work at all. Oh, I see. I put it inside a mutex. Okay. Yeah, so thread ID. So we just need to pass in thread ID. So we just need to pass in thread. Yeah, so thread ID. So we just need to pass in thread ID. And print that. Where was the ODS in here? Or is it not in here? Yeah, okay. Okay, I'm sure this is going to show us on two different threads, but let's just do that to make sure. Yeah, so thread ID. So we just need to pass in thread ID. And print that. Where was the ODS in here? Or is it not in here? Okay. No, it's not updating anymore. There it goes. Okay, way up here, thread number 2 accepted that one. Thread number 0 accepted the same one. Then thread number 1 eventually adds that and accepts the same one. Adds the built mesh, adds the built one. Okay, so they're all accepting it. So somehow they're not being prevented from doing it. So they're all accepting it. Adds the built mesh, adds the built one. Okay, so they're all accepting it. So adds the built mesh, adds the built one. Okay, so they're all accepting it. So somehow they're not being prevented from doing it. So they're how would that happen? How would that happen? The moment it prints accepting, well, not quite the moment, but almost the moment it prints accepting, it's going to end up here and set the status thing. Well, not quite the moment. The moment it prints accepting, well, the moment it prints accepting, well, not quite the moment, but almost the moment it prints accepting, it's going to end up here and set the status to processing. Is MCS a different MCS? Do we abandon that or something? Build mesh. We go in here and we start building it. We release the gen chunks. We add it to the queue. We don't clear the thing at this point. Just make sure this is like a stable piece of memory. Yeah, it's just a global variable, mesh status here. I don't know. How could that happen? Yes, reference in that is not the right one. Oh, wait, I do the get chunk status there. That is reference in that is not the right one. And yes, reference in that is not the right. And yes, reference in that is not the right one. Oh, wait, I do the get chunk status there. That is in fact correct. It might not be the right one. Well, I did it here. Why am I re-getting it? It's all inside the mutex, so actually it shouldn't change, and it should be the right one. Oh, that's what you meant by this gets reassigned right here, yeah. This should be redundant. Okay, well, we get in here. Oh, we process the whole list. Whole list. Process the whole. Oh, we process the whole list. No, it's still, but it's all still inside the manager meeting. So here's what my thought process is that maybe there are two meshes become ready to process. I process this whole list, and somehow, even though this list isn't what determines that, two things have become ready to process. So then when I get into here, I only grab the first one, and I don't do anything about the state of the second one. But that shouldn't matter, because the next thread that comes through gets the second one and updates its stats, and shouldn't be able to. All right, so let's go ahead and print pointer and value. So just MCS and MCS error status. Let's go ahead and print those and see what's going on with those. This isn't looking at the MCS. Is the MCS even available here? No, it's not, because we're not locked, which is intentional. So we can go ahead and do this. We expect the state to be processing because we set it ourselves. MCS equals. Oh wait, get chunk status. And I just put this inside here so it would be inside the correct mutex. And I just put this inside here so it would. processing because we can do this. So we can go ahead and do this. We expect the state to be processing because we set it ourselves. CS equals. All right, get chunk status. And I just put this inside here so it would be inside the correct mutex instead of being down here. Because we're never actually hitting that failure path, I don't think. A failure path, I don't think. Here. Because instead of being down here, correct mutex here so it would be inside the... And I just put this inside here so it would be inside the correct mutex instead of being down here. And I just put this inside here so it would be inside the correct mutex instead of being down here. Because we're never actually hitting that failure path, I don't think. CS is null probably. Yeah, it is null. Okay. So I guess the cache entry could get flushed by a different one being built. The post cache is supposed to be large enough that that never happens. Oh, we processes just this whole determines that. I only grab the next thread that comes through gets and value. It's even available here. Intentional. And I just put this inside here so it would be inside the correct mutex instead of being down here. Because we're never actually hitting that failure path, I don't think. This one. And I just put this inside here so it would be inside the correct mutex instead of being down here. Because we're never actually hitting that failure path, I don't think. CS is null probably. Yeah, it is null. Okay. So I guess the cache entry could get flushed by a different one being built. The post cache is supposed to be large enough that that never happens. This one. Yeah, if we abandon a mesh, then we won't ever see it in this list. What is this even doing? Why do we allocate and immediately delete it? That seems like a mistake. Oh, we delete it from the list. We don't delete it. Right. Yeah. Let's just see if we see anything suspicious there. The thing is, when I tried to debug this before, I thought I didn't see any. There were abandons, but not abandons that mattered. And that was a separate thing that part of the performance stuff that I wanted to do was to... Oh wait, I still need to do this. I would love it if somebody mails me and says there's a much simpler way to do this threading stuff, to organize it. Okay, so some things are being abandoned. A pretty significant number are being abandoned. Which is what I want to investigate for performance. It's abandoned after it's received. That's weird. Don't know. Hello, generate some more data. Why are you not generating? There it goes. Oops, I hit spacebar. Okay. So, 0, -7 happened twice. The mesh chunk status was missing. We accepted it. Had the same pointer, but its status was 2. In both times. And let's check what status 2 is. This enum. Okay. 2 non-empty chunk sets. Okay. So it has not yet updated to processing. So somehow processing. So somehow that and that, it accepted it. Wait, is that, but that's not still inside the lock. Wait, I was starting to check that and then I never checked it, right? That was the thing I was investigating and then I forgot to follow through. Wait, I was still inside the lock. Is that, but that's not still... Wait, is that, but that's not still inside the lock. Wait, I was starting to check that and then I never checked it, right? That was the thing I was investigating and then I forgot to follow through. You get next task. No, okay, inside the get next task we set to processing. So that's all inside the mutex. Am I forgetting to create the mutex? Manager mutex. Right there. Manager mutex is locked. We get the junk status. We never check if it's null here. So we don't handle the case that it's in the requested list, but it's gone null. Oh, because we only are keeping things we requested in the new list. Okay, right. So there's always valid MCS. We update MCS in here anywhere? Everywhere goes to non-empty. I remember saying this is probably a bug. I should be adding plus valid chunks in this path or something. Oh, right, but no, it's only. If it's not valid. Why do we do this? If it's not valid, then we set it to non-empty? You should only set to non-empty if it's non-empty. What? What? What is this? Oh, right. If there's a gen chunk for it. Yes, okay. I see what this code is doing. And it should add val chunks. That's probably a bug. But it just causes it to be a frame late about updating it. Unless this guy never gets woken up. I don't know what that would do. I just don't want to mess with that at the same time I'm messing with something else. Unless it turns out to be this bug, that would be very sad. All right, we printed the MCS, and the value of the MCS, it was the same in both of these. It was still not chunk status processing. We're still inside the mutex. Boom, we set MCS status chunk status processing. Is somebody else writing over it later? Does it get accepted before? Or not accepted, does it get received? Before accepted? No. The accepted happens before the first received. So the received can't be updating it. So who else updates it? Abandon updates it, but we print abandon. Finish updates it, but that's the accepted thing. But let's go ahead and ODS. But that's the accepted thing. Updates it, but that's the finish updates it, but that's the accepted thing. But let's go ahead and ODS. just in case. Never know. All right, and then the next assignment, if we allocate, so it didn't exist already. Here I set the status because it should always be safe because this stuff was 0. Let's add an assert 0. Here I set the status because it should always be safe because this stuff was 0. Let's add an assert should be one of those two states. And there we set it to processing. And that's the non-triangle case. And we've pulled the full loop. That's all the cases. Next thing I'll do is actually do an explicit. Next thing I'll do is actually do an explicit ODFs every time I assign it. It's very mysterious. Just holding on space again. All right. So the duplicate here was received chunk. I don't see a duplicate. I should have checked. I should have looked in the debugger. This has always been matched, so I didn't even, just always assumed it was the same thing. Is the link not in the Twitch back panels somewhere? Is the link not in the Twitch back panels somewhere? I should put it there. Come on, trigger the bug. Come on. Oh, it triggered that assert. Oh, it triggered that assert. All right, well, there you go, putting in the assert that it has to be true. MCF status 3, it's processing already. But we checked that it should never be processing without chunk set valids all being true. Okay, well, that's the next thing we need to assert. All zeros. So did I clear that somewhere? I do. I set it. I clear it right here. Why do I clear it there? Well, I can allow that. If MCS status does not equal status processing. Because if it is processing, we never want to do any of this stuff anyway. So it's fine to just do that. And then we can actually incorporate this test as well inside that. We can get rid of that. And actually, that is really dumb. Let's do that. Okay. 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 Maybe that'll fix the bug. Maybe that'll fix the bug. Since I think that was totally bogus. I bet that was it. The thing is, it took so long to trigger the last time that I'm a little afraid to assume I fixed it. Try again. Alright, I'm going to assume it's fixed. I'm going to take out the ODSs and then do it again, just in case. Do it again. I'm going to take out the ODSs and then do it again, just in case the ODSs were making it happen less often or something. Voila, a bug fixed. So that was kind of an important demonstration of one of the reasons I don't like threaded programs. That was kind of an important demonstration of one of the reasons I don't like threaded programs is because you end up with these queues between things, and when something is going wrong, you find out too late, and you have to work backwards up the queue to find out what was going wrong. Now, if it's non-interactive, it's a lot easier if it's reproducible. But usually, as soon as it's a threading bug, so that was kind of an important demonstration of one of the reasons I don't like threaded programs is because you end up with these queues between things, and when something is going wrong, you find out too late, and you have to work backwards up the queue to find out what was going wrong. Now, if it's non-interactive, it's a lot easier if it's reproducible. But usually, as soon as it's a threading bug, even if it's a non-interactive thing, the repro case may change because it depends on the interaction of the threads, which is independent of the, which is a sort of independent thing. There are replay systems that force threads to stay synchronized to replay the same way they are, but a simple one is not going to do that. The complicated ones have to. Well, there's two ways to do it. One is to make sure that all. So that was kind of an important demonstration of one of the reasons I don't like threaded programs is because you end up with these queues between things, and when something is going wrong, you find out too late, and you have to work backwards up the queue to find out what was going wrong. Now, if it's non-interactive, it's a lot easier if it's reproducible. But usually, as soon as it's a threading bug, even if it's a non-interactive thing, the repro case may change because it depends on the interaction of the threads, which is independent of the, which is a sort of independent thing. There are replay systems that force threads to stay synchronized to replay the same way they are, but a simple one is not going to do that. The complicated ones have to. Well, there's two ways to do it. One is to make sure that all transitions that happen when you call the operating system happen the same way, so that like all communication between two threads always happens in the same order when that communication is going through the OS. But the problem is the shared memory, that won't be enforced. So here, because I'm using semaphores, it can do a thing where it sort of forces that. If you had one of those replay systems. Yeah, okay, it seems stable. Oh, I need to get rid of the receive chunk. What was all that, Stu? Oh, right, that's still the memory debugging that I have on. Okay, so that's in world. No, in voxel render, I mean. Receive chunk. Whereas in a single-threaded app, that kind of stuff is much easier to make reproducible. Dash A, dash A, dash A, dash A. Now, I think there might still be a latent bug in this design. The one that I said in this design. Now, I think there might still be a latent bug in this design. The one that I said shouldn't be able to be hit because things are sized correctly. Which is, it's a direct map to cache. So, so depending on what the variables are configured to, the chunk for -2, 0, and the chunk for -10, 0, or let's say 6, 0, are both assigned to the same spot in the cache. And that's fine for the meshes at runtime that we're rendering, because we like make sure that our view radius or view diameter is under 8. Then you never need both of those meshes loaded at the same time. So it's okay to use a direct mapped cache. We also use a direct mapped cache for the physics. And as I've mentioned, the server physics needs to actually keep separate disparate regions around each player. And I won't be able to use that. So I'll have to do something different for the physics cache. So there's an interesting thing here in the mesh builder, which is that it's possible one thread could be trying to do this, and then the renderer has moved and says, oh, I need that one. And another thread decides to start working on that one. And if that happens, that's one of the cases that can lead to this abandoned path. Abandoned mesh chunk status gets called if you try to allocate one, and the one that's already there is in the non-empty state. If it's not in the non-empty state, if it's in the processing state, it doesn't abandon it. So I guess that's what avoids the potential bug, which is now kind of interesting. It didn't abandon it, but it's no longer in the cache. It gets overwritten in the cache. And so now if you attempt to call get chunk status for that old one, this is never going to work. It's never going to return the valid thing. So that's how MCS can be null, which we were seeing. What was I doing? Did I do bang MCS somewhere? Yeah. Oh, I guess MCS. No, okay. I don't have that anywhere anymore. So if something gets abandoned, then this can return null. But I'm assuming it can never return null here. So I need to figure out what to do if it does return null. Now, the worry is that memory could just get stranded. It's not stored in the cache anymore. So how do you get at it? And the answer is that the MCS itself is supposed to be being kept around by the thread that's processing it. But it doesn't look like it is. If we copy out data from it, but we don't actually keep the MCS. But maybe we never query it again. We were querying it here for this debugging. But yeah, we never use the MCS again, so it's okay if the MCS gets freed at that point. Now the detail that gets lost there is that, so a mesh is starting to process that. And the renderer comes along and says, I want this, flushes that out of the cache, but a thread is still generating it. Say it's really slow to generate. So a thread is still generating it. Then the renderer moves again back the other way and now wants to allocate that one. So you could have thread 1 is doing that. Thread 2 is doing that. Thread 3 comes in and sees this request, looks in the cache, but that's not in the cache. That's in the cache. So it goes ahead and creates a new one and starts building it. That might be able to happen. I think the system ought to handle that case, but I probably need to walk through it in detail and make sure it actually does handle that case. So I'll add that to the to-do list. Well, I think it's okay. What is the H debugger? What is the H debugger? Okay, so did Casey write a custom debugger or something, or just like a memory viewer or a game status viewer or something? Okay, you made a debugger. Okay, you made a debugger. So we got these two done. So we got these two done. So now we need to write a real performance monitor and a real memory monitor. I think memory is higher priority because memory causes us to run out of memory and crash. Whereas performance is just, I'm curious if we're doing something bad because it does seem to be building the train slower than I would expect. Slower than I remember doing in my old demos. I've been going, what, an hour? I really wanted to get to some of this, but I'm a little tired. Let's survey what needs to get done. How about that? And I won't actually do it. So, what we want to do is classify every allocation. We've already done this, right? We've got the file and line stuff that I did. I think I used the built-in stuff. I think we decided that the fastest solution was to use the built-in stuff instead of trying to use my own leak check stuff, right? We were using the CRT debug stuff. But it had bad interactions with STBH because the allocations happened inside STBH, and that was kind of a problem. So what I want to do, what I've done elsewhere, is mark up each allocation explicitly instead of using file line, give it an explicit name, sort of quote-unquote name. And the thing to do that I've, for a large enough system that I was doing elsewhere, is that you give it a name like, you know, say, let's find an allocation. Oops. Nope. There we go. Oh, no, it's searching the wrong subtree. This is one of the sad things in PC6 is it gets that stuff wrong sometimes. So I just clicked the wrong one. Okay. That one. Okay, so the thing to do is to mark this up. That one. Okay, so the thing to do is to mark this up. You just add, you change it from malloc to my malloc or whatever, and you add a second parameter here. And so this is, it's going to just be a gen chunk. You might want to qualify what kind of gen chunk it is that it was allocated for the purposes of the proc gen, you know, or something like that. If there were multiple ways that we're generating gen chunks, you might do that. Then what you do is you add a hierarchy. It's like a file system hierarchy, and you say this is part of, you know, what system is this? This is part of the proc gen. And so if you're going to do that, you don't really need to prefix it with that. And generate chunk. It's a lot easier to do it as you're writing the code instead of trying to put it in hindsight. So it's part of the proc gen system. It's probably part of the worker threads. So you might want to say worker, because the worker threads do proc gen and they do mesh building. I think the mesh builder doesn't do mallocs, but maybe it does. So you do something like that. And then when you want to query the memory usage, you can say, you know, what's all the memory usage for just worker memory usage allocations. You can say, what's all the memory usage being used in the proc gen? And then you can look at the specifics, the gen chunks. So you can create some kind of hierarchical viewer that lets you see what's going on in the memory. And, you know, the way people do leak checking classically is they keep track of all of the allocations. And then they, like, on shutdown, they free everything. And then they check that they freed everything that they allocated. And that's a pain in the ass. And it can miss a certain kind of leak where you have a system that doesn't need the memory anymore, but it's keeping around a pointer to it with oversight, and during your cleanup code does free it. Then you won't see that as a leak. So another way people have done that is that so that you don't have to free everything, is that you do the same kind of existing markup with file line or whatever, and you put in, you trigger a marker, like say a frame, you know, after 2 seconds you trigger a marker. I don't tell you what that means in a second. And then after 10 seconds you trigger another marker, and you compare the status of the heap at those two marker states. So when you trigger a marker, it has to record the whole status of the heap basically. And then when you trigger the second time, it says, well, what's new from that last time? And that, you might have legit stuff allocated, but you can see like, oh, I have, you know, if a system is supposed to allocate like the same line is supposed to allocate like 20 times during start, but never again, and it keeps allocating 20 times every frame, you'll notice that, hey, there's, you know, the difference between that the after 1 second and 10 seconds is pretty big. And that's useful, but because if it's only file line based, it's hard to get that much data from. If you just do this, then you don't actually even need the delta stuff so much, because you can just go, hey, after 10 seconds, how much memory is in use at the top levels? And then after 20 seconds, how much is in use in the top levels? And if one of them, if you have a big leak, one of those subsystems will have grown by a bunch. And then you can just keep narrowing down through the subsystems and find which subsystem is growing. So I'll do something like that. Obviously, like I said, malloc has to be replaced with some other kind of thing. So, you know, I don't know, yalloc or something. So the problem is that the stba.h stuff doesn't get marked up, and it's a pain in the ass to try to do markup on it. I've discovered doing this project because I've never tried to use stba.h on this kind of thing. So what I'm going to do is I'm going to take stba.h. Why is it not in my dependencies list? Oh, it's in libs. So I'm going to go to stb.h and find stb array push. So So here's the STB array thing that I'm using for the variable length things. And what I'm going to do is I'm going to just if-def this out of stb.h and cut and paste and keep my own private copy of it in OBBG. And that way, that own private copy, I can now add markup to it where I add the realix and the malix can get a markup tag that's passed in to the array push function that will let it do the same kind of annotation. Because I don't want to bleed that into stb.h itself. And so that will mean I'll have to change all the STB array pushes in OBBG to have that markup. And then if there's any other allocations happening in stb.h that matter, I don't think there are, but if there were, like I use it for file loading and stuff like that, but that stuff isn't leaking. I might be failing to free it, but it's not an ongoing increasing leak. So I think just doing STB array will cover that. So if I do that kind of markup and write some kind of interactive viewer for it that shows in the top corner, shows the tree, I think I'll be able to figure out where the memory is going, and maybe we'll see if there are some memory leaks. So that's the plan for the next time. So we'll do that. And then we can look at the performance monitoring. And the performance monitoring, it's more than just performance. It's that, like those meshes being abandoned, I want to sort of track that stuff. So not just low-level performance monitoring, but some actual understanding of what the thread jobs are doing. Not just the jobs, not a job system viewer, but a system that's understands what that's very specific to this task. It's like, oh, you're creating chunks, but these chunks are never getting used. They're just getting abandoned. And you're creating meshes, and the meshes are getting used or abandoned. Keep track of stats on those things so I can tell what's actually going on. Because I suspect the performance problems that I'm having here may be things like that, rather than write your loops better. It may actually be just doing work that's being discarded and stuff like that. And who knows? That may not be the biggest area for improvement, but it could be the biggest area for improvement. So I really need that kind of data. Okay, so I think I will. Okay, so I think I will wrap now, since that's been 5 hours between the two streams. So yeah, if anybody has any questions, let me answer them now, and if they don't come in fast enough, I will stop the stream and answer in chat. And yeah, as I've said before, I really only started using Git because for GitHub, for the STB libs to accept pull requests and stuff, and have explicit issue tracking. Because when I wasn't using GitHub, I ended up with people sending me the exact same fix for STB Vorbis dozens of times. I don't know how many times, but I got the exact same fix many, many times because I just never got around to updating it. And because it was a minor fix that some static analyzers were showing a free that was missing or something, but it was only on an error path, so it wasn't very important, so I never got around to it. And but everyone kept running their static analyzer and finding the same bug or whatever. So I've decided I should really put it on GitHub so that then there's an issues page, and then maybe people notice that the issue is already there. And that turned out to be a good thing because then you get the pull requests. All right, so nobody has any questions that have been improved. Nothing's will the Linux pull request ever get merged? Yeah, that have been improved. Nothing questions that nobody has any. All right, so nobody has any questions that have been improved. Nothing's will the Linux pull request ever get merged? Yeah, so the problem is that I do my FTB updating once in a while, the GitHub pull request merging, because it's a bunch of work. It requires me to get in the mental space, and so it doesn't take a whole day or anything, but it kind of ruins a day. It's probably a couple hours, and I only have so many weekends, So it tends to be about once a month, probably ballpark, that I do it because, like, basically give up one weekend day, kind of. It's not really, maybe half a day. Um, and and the thing is, that's the SDB stuff. And I just never even think to go look at the OBBG pull requests, like that when I'm doing the SDB stuff. So probably what I need to do is much like this annotation thing. Miblo had sent me 7 episodes worth of annotations, and I still hadn't written. I told him, send me the annotations. I'll write a tool to do it. And I just never got around to it. So I was like, I better just make that be my job on stream, so that I have an excuse to get it done or whatever. So maybe I have to do the same thing. Maybe I'll have to do the pull requests on stream.